Students interested in chemistry should have certainly acquainted themselves with the term hydrogen. So we're talking about a very important recent topic that is intended to revolutionize our energy sector, and because the major aim these days for all the countries the world over is to decarbonize, that is to reaffirm our independence from the fossil fuels. There are a lot of summits regularly happening year after year, whether that be the Glasgow summit or the summit at Sharm el Sheikh or at Dubai. So all these summits where India wants to emerge as a leader in green technology, the green hydrogen becomes very important for us to discuss. So let's rejig things a bit. Although I have a storytelling method, but let's try reverse engineering for a new approach. So there is a question in front of you right now. Just go. You can pause the screen and go to that question. So there are some statements about green hydrogen particularly. So renewable energy, green hydrogen fuel cells, higher efficiency, gray hydrogen. Okay. So we'll discuss in the subsequent slides as I come and draw, and it is going to be very interesting. You just have to bear with me. Although I speak very calmly and not in a sensational manner, but I'm not going to tell you the answer right now, not because I want to do increase my views or increase the viewing time. No, that is not the main aim. The main aim is to emphasize the importance and make you work hard. Even if you just solve this question and try to find it from the internet, you decide not to view the rest of the videos, you can go ahead and do that. And in fact, this question itself covers a lot of concepts. So whenever you are free, you can just look at the options and try to figure out what the correct option is. So this is a sample question which I have created. It pertains to the recent trend that the UPSC has been following, and jugaad or that elimination method which we commonly rely on will not work here. You need to know the exact statements. Okay. Next, we have this sample question. This is a means oriented question. So it's worth 250 words. Again, you can note down this question and you can send the answer. You can attempt it and send the answer to me on mail, and I'll definitely check it and get back to you. Fine. So so we're talking about green hydrogen. Okay. So hydrogen fuel cell might be an astonishing fact for most of us to know that this fuel could release more energy in comparison to diesel or petrol. Obviously, we are talking about green hydrogen. You are already acquainted with what is known as the electric vehicles that use the lithium ion battery, but it has several shortcomings. We'll come to that. We'll discuss them in brief, as the major topic of discussion today is green hydrogen. And hydrogen is the main fuel. That is true, but fuel cells do require oxygen because oxygen is a must for combustion. One of the main appeals of fuel cells is that they generate electricity with very little pollution. Ultimately, in the starting of the slides or presentation, I told you that that is our main aim the world over. Apart from India, all the other countries, developing, they are trying to decarbonize or reduce their dependence on fossil fuels such as coal, petroleum, natural gas, and the like. So much of the hydrogen and oxygen used to generate electricity ultimately combine to form an innocuous byproduct, namely water. So water or water vapor. Each fuel cell also has an electrolyte that carries electrically charged particles from one electrode to the other, and a catalyst that accelerates electrode reactions. Now I'll draw a diagram to discuss in a lucid manner. Don't worry about all these terms. You don't need to go to the 10th class NCERT and study mentally and the periodic table and all that. It's just the simplest element with an atomic number of 1. So it is going to be very interesting. Again, I'm very interested. I've spent considerable amount of time to prepare this topic and presentation for you. Hopefully you will enjoy it. So our main agenda for today is green hydrogen. Again, we are talking about decarbonizing. Even our transport minister, Mr. Nitin Gadkari, has emphasized a lot on hydrogen power. So the main agenda is whether it is a fuel for hype or fuel of future. So some basic data you can study or just for information again. So it is the most abundant chemical structure in the universe. Now in the geography NCERT class 11th, in the physical part, you will see that most abundant element, because the majority of the gas is consist of hydrogen. The hydrogen is the basic fuel in the sun. When we talk about the sun, the fuel for what we know as fusion, the process of the production of energy in sun and in general stars, is not coal, petroleum, natural gas or carbon based compounds, but it is hydrogen. Okay, it is different from fission, which we observe in the nuclear bombs and nuclear reactors, which use the radioactive materials such as plutonium or thorium, or there is the most common uranium. Okay, for which Iran keeps getting into trouble of sanctions anyways. So the gas itself is invisible, then also we talk about various colors of the gas. We'll get to it. So the basic is hydrogen means creator of water. So H2O, the atomic number is 1. I'll get to it. Basically hydrogen consists of one proton and one proton and one electron. So that is the basic structure of hydrogen. And we have isotopes of hydrogen also. That is, we have the deuterium, tritium, because of the presence of an additional neutron in them. We'll not go into that. Okay. So what's with all the fancy colors? So you might have come across gray, blue, and green. So although it is green hydrogen, we call it as green hydrogen, but we have already discussed that hydrogen in itself is invisible. Green hydrogen means that the again, hydrogen is the most abundant in the universe, but in our Earth's atmosphere, the most it is found in very little quantity. So we have to resort to other compounds, predominantly water, or we can talk about natural gas, which consists primarily of methane, or other such hydrogen intensive, hydrogen containing products, and we have to separate the elements in that to produce hydrogen. So when the hydrogen division, or when the process to produce hydrogen, the energy to produce hydrogen is obtained from a renewable source such as solar energy, wind energy. So in that case, we call it green hydrogen. Just follow my cursor here. So green electricity means electricity generated from the renewable sources of energy. Okay, so basically green electricity is used for the electrolysis of water. I'll come to that by diagram, just wait. Blue hydrogen, again blue hydrogen, do not confuse it with the hydrogen derived from ocean water. All hydrogen, most or more or less, is derived either from natural gas, methane, or water. Blue hydrogen is where the hydrogen is the fuel, but fuel has to have a source, should have a source, and the source of producing hydrogen, or source of power to dissociate hydrogen, is provided from natural gas, which is a non-renewable source of energy. But in that case, the carbon emissions which are released, you'll study this topic in detail. This is a topic, there's a term, a phrase known as the carbon capture and storage. So whatever carbon emissions are taking place due to the hydrogen produced from natural gas, obviously natural gas, when it natural gas is CH4, methane. So when hydrogen is separated from methane, so one of the byproducts will be carbon dioxide, and it is harmful for the environment. So in case of blue hydrogen, the CO2 is stored underground. Okay, now majority of the hydrogen which is being produced by nations world over for the time being presently is the gray hydrogen. That is again the source of power to produce hydrogen, or to separate hydrogen from its compound in which it exists, is the natural gas. But unlike the blue hydrogen, the CO2 emissions are not stored underground, as in case of blue hydrogen, it is released into the atmosphere. So it is also a non-friendly way for the atmosphere. Although hydrogen in itself, when it is combusted, when it is used as a fuel, again the end product is water vapor, which is innocuous. It does not harm the environment, but the source or the energy which is used to produce that fuel, in this case hydrogen, remember hydrogen is a fuel, natural gas is the compound from which the fuel is derived. In case of green hydrogen, water is the source which is undergoing electrolysis. I'll demonstrate it why with the help of a diagram. Electrolysis is causing the water to break into hydrogen. Okay, and that hydrogen then is used as a fuel for the production of energy. The fuel combines with oxygen, as is the process in all these type of hydrogen, that is gray hydrogen, blue hydrogen and green hydrogen. The fuel is hydrogen and it combines with oxygen to form water vapor. But the, so again I am repeating or reiterating, the source of production of hydrogen may be in this case it is not environmental friendly, and as it is dependent upon the hydrogen extraction from fossil fuels. In this case green hydrogen, the electricity is derived from renewable energy. Okay, so we'll get to it. So first of all, before we get into the types of EVs, one very interesting topic. So I'm quickly going to draw an illustration of a hydrogen fuel cell which will help you understand how the fuel, that is hydrogen, is actually entering. It is a very simple illustration. Don't think that the fuel stack in a fuel cell electric vehicle will be as simple as this. Just give me a moment please. So I'll just do one thing. I'll try to distinguish the compartments. Fine. So this is the major structure, basic structure of the hydrogen fuel cell. Right. So here, if you remember a bit of chemistry, there are two electrodes majorly in any cell. So this is H2. Now remember, I'm just talking about the hydrogen fuel cell. The hydrogen has already been derived either as the in the form of gray hydrogen, that is from methane, CH4 natural gas, or by the electrolysis of water. Okay, so the H2O has been divided into H2 in from electricity in this case, and here also in case of natural gas it has been derived by a process known as steam reforming. Okay, I'll just mention these terms, no need to go into detail. So now the basic reaction of combustion, that is the fuel which combust, hydrogen fuel, this is the basic equation just for your knowledge. So 2H2O plus energy is released which drives the motor or axle, that is the car. Here there is a catalyst which helps speed the reaction, fine, and here there is the oxygen, here the H2O or the water in the form of water vapor, which is an innocuous gas, that is why we are focusing upon green hydrogen. Okay, this here is the electrolyte, which is a medium which helps in the transport of ions. Okay, so here what happens is after the hydrogen passes through the catalyst, the H atom, the basic structure of the H atom is that there is a proton and there is an electron. Okay, this is the positive. Okay, H positive, the hydrogen ion, Hydrogen ion is nothing but a proton. So here what happens is it gets divided into H plus and electron. Fine. Now this membrane or electrolyte, which is a solution, this electrolyte is semi permeable. It allows the H plus ions to pass through it, but it does not allow the electrons to pass through it. Fine. And here we have O2. So this, now what happens? We know that electrons also need to find a way to travel because an electron is highly unstable in itself. So what we do is we connect a wire here, and so the electrons start flowing from this terminal to here. No need to go into detail. This becomes the anode and this becomes the cathode. Fine. In this case negatively charged electrode, and in this case the positively charged electrode, the cathode. So here when the electron is going here and the H plus is traveling through here, the H plus again it combines with the electron to form the hydrogen, and the hydrogen then combines with the oxygen, and this reaction is produced. This is the basic, no need to go by the actual, this is just to make you understand the concept. And we know that the production and transportation of electrons leads to what is known as, that is electric current. So electric current is being produced, and if we place a bulb in place of it, so it will lighten up. So similarly this in place, if we connect a motor, an electric motor which powers the car, which helps the car move, so this is the entire scenario, which is what is happening in the fuel cell. So getting back to the main topic, now another interesting parts, there are types of electric vehicles. Okay, so also we are just focusing, we have to just focus on the FCEVs, the fuels electric vehicles which use hydrogen as a fuel. It is pertinent here or important here to discuss or compare between the different type of EVs. So I have put some Indian examples, some Desi examples so that you can understand and relate to it. So I've also put icons here so that you can easily. So first, if we discussed about the HEVs, that is hybrid electric vehicles. So here, like this is Toyota Hyryder Hybrid. Okay, you might have come across it. Then they combine the conventional IC system, that is internal combustion engine, which uses gasoline, and it is combined with an electric propulsion system, that is the battery, and that lowers the fuel usage. You might have seen that Toyota Hyryder, these hybrid electric vehicles, they have a much higher mileage as compared to the ordinary or combustion or conventional ICE system vehicles, because they use both battery and this gasoline fuel. So what is the important point in this is that this is only hybrid electric vehicles. The battery does not need to be charged separately through an electrical outlet. When the battery is depleted, this gasoline engine comes into play and it charges the electric drivetrain. So what I mean to say is here that when there is low load, the electric motor plays, and when the demand on the engine is more, the gasoline engine comes into play, and also this gasoline engine or gasoline derived energy is used to replenish the battery here. Then we have plugged in hybrid electric vehicles, like this is an example of Chevrolet Volt. Plugged in hybrid electric vehicles are not very conspicuous in India due to cost purposes and other. So here again, the like in hybrid electric vehicles, the concept is same. But what is happening here is that apart from gasoline and an electric drivetrain, the drivetrain can also be charged by plugging the vehicle or the battery with an electrical outlet. So it can be plugged into a power source. Then we have BEVs, which are currently in trend all over the world. So here there is no ICE or fuel tank. The dependence on gasoline is entirely eliminated. There is also only a battery pack or battery powered electric drive train which is charged. You might have seen some outlets. So, like Tata Nexon is a highly good selling, best one of the best selling BEVs. And then we have the proper hydrogen vehicles. Hydrogen powered vehicles, they again have a fuel cell. So this is different from a lithium ion battery, which is being used in the conventional electric vehicles or BEVs. But here we have a hydrogen powered battery. And here, unlike here, the hydrogen powered vehicles cannot be charged with an electrical outlet. It has to be refueled. The hydrogen has to be refueled in the hydrogen tank, like in case of gasoline. So are you understanding the meaning? Okay, so this is the basic structure. And then we have challenges in adoption of BEV. So already we know we have to first understand what are the challenges in adoption of BEVs. Why Mr. Nitin Gadkari or other nations across the world, they want to bring the fuel cell electric vehicles into picture. So in BEVs, already there is a high upfront cost. So in countries like Norway, US, and China, it has shown that electric push works only if it is backed by state subsidies. But in countries like India, again the upfront cost is very high. There is a huge difference if you purchase a Tata Nexon, electric Tata Nexon, and a or traditional ICE engine built vehicle based on gasoline. And moreover, the subsidies in the form of tax breaks often benefit the middle or the upper middle classes because they are the primary purchasers of electric four vehicles, so they are yet to reach a broader demographic. Okay, then we have charging infrastructure. Obviously, the charging, if you some people are very concerned about the charging stations. For example, in a city like Delhi, there are still some stations, the standalone stations which have been developed, or people have built stations, their personal stations, which the outlets are they are connected to the house power transmission structure or grid, and they can easily charge their electric vehicle. But if we go to other cities, if you're planning a trip outside Delhi and you in rural areas, okay, so it might become a headache because finding a gasoline or a diesel fuel pump is much easier as compared to a charging infrastructure. And also it is dominated by two and three wheelers. You might have heard of Ola scooters. Okay, so a lot of people are also dependent upon the two and three wheelers. And not to mention you these there are the notorious e-rickshaws which absolutely have no regard for traffic rules and are sort of a menace on the roads. But anyways, then there are supply chain issues. You might have heard of a term known as lithium triangle. So more than 90% of the global lithium production is concentrated in Chile, Argentina, and Bolivia. These countries in South America, they constitute what is known as the lithium triangle alongside Australia and China. And apart, not only the only not only the sole material or element which is used for the construction of the electric battery. Other elements like cobalt and nickel, which are mined in Congo and Indonesia, they are also used. So obviously these are limited in resources, and lot of issues, lot of international relation concepts come into picture. I'll just mention a few terms. Like you might have come across the uh, concept or term known as polymetallic nodules, the deep sea, which are associated with deep sea mining. It was much in news. That is the open sea treaty. You can just go and search on Google. And also it comes at a great human cost, because if I'm mentioning a country like Congo, here there is a manual mining of minerals like cobalt. Okay, so the people are also exploited there, so that is there. And the supply chain issues, again, there is a very small pool of countries to cater to its demand. India has to depend on other countries. And then there is consumer awareness, consumer preference, although in recent years has increased, but again the resale value, the loyalty, and that you may call it a stereotype of preference to the comfort, because again, like I said, when there is a less amount of charging infrastructure, the consumers, they tend to rely on comfort, because if you are stuck in a place, it is very difficult to find charging infrastructure. Relatively easier to find the conspicuous the petrol and diesel outlets. Okay, so but big Indian commercial vehicle manufacturers such as Tata Motors, Volvo, Eicher, and Ashok Leyland are doubling down on efforts to develop hydrogen-powered trucks, and Indian energy companies too are trying to scale up production of green hydrogen. Okay, so we have also discussed that even though hydrogen is still in developmental phase, but it is much more efficient. It has a low energy density, but it is highly efficient as compared to burning gasoline. Right? So we had discussed about the challenges in BEVs, and now we have to analyze where do FCEVs, fuel cell electric vehicles that are powered by hydrogen, they stand. So here I hope you recognize this symbol. So this is Shell. So in countries, now Shell is one of the major hydrogen has owns one of the major hydrogen plants in California, but the transportation and storage costs have become so much, so that has made the distribution and the viability of use of hydrogen in vehicles and transport sector very difficult. So these are some of these include both the disadvantages and advantages of fuel cell electric vehicles. So there is a prohibitive cost of production, followed by challenges of storage and transportation and scale. Now what we have to, why the storage and transportation? Firstly, we know that hydrogen cannot be directly used. It has to be extracted either as gray hydrogen or as green hydrogen. Again, I am repeating, gray hydrogen from natural gas, that is methane, by steam reforming process, and green hydrogen by renewable electricity. So that also, for green hydrogen, production of green hydrogen, we have to use energy from the renewable sources such as solar power and wind power in order to perform electrolysis and divide the water into hydrogen and oxygen, and then only we can use hydrogen in the fuel cell electric vehicles. Then hydrogen is extremely flammable, which means that special care has to be taken in handling fuel at retail stations. And already we Indians are highly so-called responsible in handling gas leaks and all. I don't need to mention and emphasize this fact. So that is a major issues. And compared to BEVs, FCEVs are typically much lighter. So this is a major advantage over the BEVs. Like Tata Nexon, you might have heard one of the major disadvantages of these BEVs is that the lithium ion battery structures or battery packs, they are very heavy, but hydrogen is a very light element. Then most cylinders manufactured in India are designed to carry compressed natural gas. So if we are trying to promote the use of hydrogen in the domestic sector, transportation aside, in the domestic sector, hydrogen has to be can be contained in a cylinder at a very high pressure, much high pressure as compared to compressed natural gas or CNG. So that also is a major hindrance or obstacle for the transportation or storage of gas. Fine. And of course, when we talk about the powering of transportation vehicles like trucks, then this becomes then this becomes very feasible or viable alternative as compared to the normal electric vehicles, which can highly increase the cost in case of the transport sector. Fine. So this I have given some icons like cost, then flammable, then light as a feather, and high pressure. Okay, significance of green hydrogen. This is majorly theory. So this I have been repeating since time immemorial, since the beginning of the presentation, that you might have heard of this internationally nationally determined contribution targets, that is to decarbonize the Indian economy, the pledges, one of the pledges that India has taken. Then in terms of mobility, again green hydrogen is light, and the freight and transport sector can really highly benefit as the technology develops. It will become highly feasible. Then green chemicals like ammonia and methanol can directly be used in existing applications. We don't need to go into depth. You need to know the fodder points or the essential points to diversify your answer, which will help you in mains. Then green hydrogen blending. 10% may be adopted in CGD, that is the city grid networks distribution, the city grid distribution networks, to gain widespread acceptance. So you might have heard the ethanol blending in petrol. Similar to that, ethanol blended petrol is currently being used on a small scale in to power vehicles. And finally, we have renewable energy that cannot be stored, like excess solar energy or excess wind power. It can be channeled into a grid or linked to the main power grid to transmit and produce hydrogen. Fine. So now, lastly, the government initiatives, which are very important because you need to know what is happening on the side of the government, how the central government and the state governments are acting in cohorts. Okay, so the MNRE, the Ministry of Non-Renew and Renewable Energy, it has announced rupees 496 crore scheme to support pilot projects for testing the viability of green hydrogen. Okay, then validation of technical feasibility and performance of green hydrogen as transportation fuel, evaluation of economic viability, demonstration of safe operation of hydrogen-powered vehicles and refueling stations. One point just came to my mind. The government had previously also announced the National Hydrogen Mission. Okay, so I had mentioned in one of the previous slides this Tata, Volvo, Eicher, and Ashok Leyland. They are also doubling out or and as a metaphor, they're stepping on the gas to produce or make green hydrogen as a more viable alternative. So this is the basic, short and sweet or lucid explanation, which I hope you enjoyed. So this is some a lot of other information I wish to share, but that will go off topic. I'm trying to be more focused this time around. You can give your feedback also. So ultimately, fuel of the future. Then, so International Energy Agency has said that hydrogen can play a very important role in decarbonizing and reducing dependence on fossil fuels. And to make a real energy contribution, hydrogen will need to be used in sectors where it is absent. And unless the upfront cost or the cost of adoption or transmission and storage is reduced, it will not be very feasible. So at the end, we can also say that green hydrogen promises significant reduction of emissions to help slow global warming and climate change. But again, curbing pollution, meeting its climate goals, costly reducing dependent on imports. This Russia, US, always they are at loggerheads, and it can also India has a great opportunity to become a business hub, a global hub for the production and export of green hydrogen. So there are challenges as well as opportunities in this green hydrogen sector. Okay, so thank you for viewing this presentation. If you have any questions or if you want to attempt an answer or send that prelims answer or the mains question, you can send it here, and we'll meet again. Till next time, Jai Hind.